Hello everyone, I'm Abdul Majid Siddiqui and I will be delivering a series of lectures on chemistry topics in a simple way. And in this regard, the very first topic that I have chosen is about the nomenclature of organic chemistry. But before we go to the topic, let's begin or revise some basics of organic chemistry so that you will be able to understand, comprehend the upcoming topic quite easily. So let's go to my desktop. So as everyone knows that each and everything is made up of atoms. It's me, you, book, plant, or any other organism, living organism, non-living organism, all are composed of tiny particles called atoms. So what is the definition that you can see there on the screen? That atom is something which is the smallest unit of matter. You also know that that an atom has three fundamental particles: electron, proton, and neutron. Proton and neutron reside. We can find proton and neutron in the center of an atom. What do you call that center? The nucleus. So we can say that proton and neutron we can find in the nucleus of an atom, right? Whereas electrons revolve around the nucleus in various energy levels, in various shells, right? Okay. And another important thing you can see that you know that protons, neutrons, electrons are the particles of atom. Now, if an atom has only one proton in its nucleus, then it has different values as compared to that one which has two protons in its nucleus. For example, if we have one proton in an atom, we call it hydrogen. If there are two protons in an atom, we will not call it hydrogen, but it will be called what? Helium. Okay? So, similarly, if three protons in the nucleus of an atom, we call it lithium. Four protons in the nucleus of an atom, we call it beryllium. Five, boron. Six, carbon. So, it means as the number of protons changes, the properties, the characteristic of the atom changes. It's like the roll number or seat number, right? As the seat number changes, the detail about the student changes, right? So scientists given this proton number a name which is called atomic number. So what is atomic number? Atomic number means the number of protons present in the nucleus of an atom is called its atomic number, right? So suppose an atom of sodium has 11 protons, so its atomic number will be 11. An atom of nitrogen has 7 protons, so its atomic number will be 7. An atom of uranium has 92 protons, its atomic number will be 92. Right? Now another term, as I told you, that protons and neutrons are present in the nucleus of an atom. They are called nucleons. If we add protons and neutrons, which are present in the nucleus of an atom, suppose there is an atom in which 6 protons and 7 neutrons are there. 6 and 7, let's add them. 6 plus 7, 13. So after adding we got 13. So 13, this is called mass number. Okay, so what is mass number? The sum of protons and neutrons present in the nucleus of an atom is called mass number, right? Mass number means the sum of protons and neutrons. Now next, if you have a substance in which all the atoms are alike. What do you mean by the word alike in chemistry? Alike means having same number of protons. Alike means having same number, same atomic number. Means you have a thing, you have a substance in which all the atoms have same atomic number. Then we call that substance as an element. So element is something in which all the atoms have same atomic number, have same number of protons, have same characteristics, properties, everything, right? So there are how many kinds of elements are there? There are 118 kinds of elements are there, which are arranged in a table, which is called periodic table, right? So out of these 118 elements, some are solids, some are gases, some are liquids. Now, each and everything is composed of, out of these 118 elements, water. Water comprises of just two elements, hydrogen and oxygen. Carbon dioxide comprises of carbon and oxygen. Glucose, it has carbon, it has hydrogen, it has oxygen, blah blah. Our body has carbon, hydrogen, oxygen, calcium, or calcium, whatever you say, potassium, or iron, etc. So each and everything made up of these atoms. Element plus element forms compound. Now scientists have seen that carbon is that element which forms biggest number of compounds. Means the compounds in which carbon is present, right, is not are not in hundreds or in thousands, but in millions. Carbon forms millions of compounds. That is why carbon is given a specialty. What is that specialty? That the compounds of carbon are going to be studied under a separate heading. What is that heading? Organic chemistry. So what is organic chemistry? Study of carbon and its compounds. Later on, scientists have seen that beside carbon in all the organic compounds, hydrogen in most of the compounds, hydrogen is associated. So they changed the definition a little bit. The study of carbon and hydrogens, or study of hydrocarbons and their derivatives. What do you mean by the word derivatives? Obtained from. So all the compounds of carbon and hydrogen and the compounds which are obtained from those hydrocarbons. These are called organic chemistry. Some of the organic compounds, number of organic compounds are there, and all of these organic compounds have carbon. So what is the symbol of carbon? The symbol of carbon is C, right? Now the carbon, the valency of carbon is 4. Who proposed this? Mr. Kekulé. Kekulé proposed the valency of carbon is 4, right? Let's go to the board. That the valency of carbon is 4. What does it mean? It means, when you know that the symbol of carbon is 4, right? So whenever we draw carbon with valencies, we should write 4 dashes around it. Not more than 4 dashes, not less than 4 dashes. The form, the shape, appearance, it could be different, like it's like this, or like this, or even like this, or like this, or any other form. But remember, you should draw only 4 dashes which represent what? The valencies of carbon. So what is the valency of carbon? 4. Each and every time when you draw the structure of carbon showing the valencies, you should draw 4 dashes around carbon, whatever be the form is. Okay? Who gave this concept? Mr. Kekule. He proposed the valency of carbon is 4. Now, before we proceed further, another question. What is the reason that carbon is having such an enormous number of compounds? What is the reason? So here comes a term called catenation. What is catenation? It's the property of an atom to bond itself with the atoms of its own kind. Right? For example, suppose if we have a piece of iron, then its atom will be side by side like this. Okay, they will just like this. Means, suppose here is an atom of iron, here will be another atom of iron. They will be just side by side. Or number of atoms of carbon. I'm sorry. It's iron. So number of iron atoms are there, right? But in case of uh, carbon, what if we have a piece of carbon, like the atoms are here? Here, what happens? They develop a linkage. Okay, a bond is formed. A relationship is developed. Means carbon has the ability to bond itself with another carbon on its left or right or up or down or any other side, right? This property is called catenation. Means if we have carbon like this, 1, 2, 3, 4, and another carbon, then what happens? They develop a linkage. This linkage is called, this property is called catenation property. If we have another carbon, they can develop another linkage. If we have another carbon, they can develop another linkage. Means carbon has the ability, well, not only carbon, but also some other elements like phosphorus, oxygen, sulfur. They also possess the same silicon. They also possess the same sort of property called catenation. Right? Now, let's go to the screen of the laptop again. So what have we just covered? That Mr. Kekule is the person who proposed the valency of carbon is 4. What else? We have covered the property of catenation that exists not only in carbon but also in some other elements like phosphorus, oxygen, silicon, etc. Now we proceed further, but before this, I would like to show you some organic chemicals. Like we are continuously talking that carbon has so much compounds, enormous number of compounds. So where those compounds are, all of such compounds of carbon are around us. Most of the things that we see in our daily life, in one way or the other, are the compounds of carbon. As you can see, DNA, deoxyribonucleic acid, various medicines, materials are all around us, plastic, clothing, essential oils, vegetable oils, margarine, butter, proteins, carbohydrate, etc., etc. All of these are the compounds of carbon. Yes, alcohol, glucose, sugar, these are the compounds of carbon. Right? Now, before we proceed to the next, there are some prefixes which are extremely used in organic chemistry. Without memorizing these prefixes, we will not be able to understand, to comprehend the upcoming topic of nomenclature or any other.
So, what are those prefixes? Suppose we have a compound of carbon in which there is only one carbon. Okay? Valencies. How many carbon it has? One. So we use the prefix met or met. How many carbons? Just one carbon. We use the suffix met or meet. If there are two carbons which are like this, short form is C2, we call it eth. If there are three carbons, we call it prop. If there are four carbons, we call it but. If there are five carbons, short form is C5, is called pent. So, for one carbon met, two carbons for eth, three prop, four but, five pent. If we have six carbons in a compound, 1, 2, 3, 4, 5, 6, its short form is C6, we call it hex. Skeletal form of, I am not bothering to fulfill the valencies, but to show the carbon which are connecting with each other. So 7 carbons, C7, we call it hept. 8 carbons, we call it oct. Similarly, 9 carbons are there, we call it non. If 10 carbons, we call it dec. 11 carbons, we call it undec. 12 carbons, duodec. 13, tridec, etc. So what are the prefixes that you should remember? These prefixes. Without knowing these prefixes, we won't be able to study organic chemistry properly. Okay? So what is your first homework assignment? Just to learn all of these prefixes by heart. For example, someone asks, how many, a compound has 5 carbons? What is the prefix? You say pent. 7 carbons, hept. 4 carbons, but. Right? If someone asks, how many carbons in oct? 8. How many carbons in prop? 3. So you should remember it. Okay? So I'm going to show these prefixes on the screen of the desktop also. Let's go to the desktop.
Okay, so 1 carbon, met, 2 eth, prop, but, pent, hex, hept, oct, non, dec, undec, duodec, etc. You have to remember so that you will be able to understand name, the method of giving name of this compound which is there, you can see at the bottom of the screen, right? So here I'm going to end this first part. Next class will start from the revision of these prefixes, then we'll proceed to the next. Thank you so much. I hope you have understood these basics. As usual, please subscribe and click the bell button. Thank you. Take care.